Hello everyone, Sagar this side. So we are waiting another 2 minutes and we get started.
Okay.
All right, we can get started now. So as you know, my name is Sagar and I would be the trainer for this batch, Cisco ASA FTD. I hope you guys can see my screen. So let me put some agenda that we would go through ASA FTD. Now, those guys who are aware of ASA and not aware of FTD. So let me tell you, this is the traditional firewall, which is now end of life. And this is the next gen firewall, which most of the companies have their in network. Okay. But to understand FTD, you need to start from ASA. So once you know some basic ground line about firewalls and ASA, what is ASA, a traditional L3, L4 firewall, then it's easy for you to grab the FTD knowledge. So this is why we will start with ASA for the first few classes, and then we will start up with the FTD part. All right. So quick introduction about what Cisco ASA is and what is this from the perspective of firewalls, the different vendors, etc. So where does this stands up? Do anyone know the full form of ASA?
Adaptive security appliance.
Sorry.
Adaptive security appliance.
Okay. Cisco ASA, Adaptive Security Appliance. Now, this product was launched way back in 2005 May. But you know that internet evolved 1980s. So was there no firewall in this time frame? There was Cisco's firewall, which was called as PICs. The PICs were a very basic in firewalls and which were capable of only uh, a basic policy and might be only the NAT translation, nothing else. And at those time, there were also some more blades that used to be introduced. There was something for Cisco IPS, Intrusion Prevention System, in 2008. And there was something for the VPNs, a different device or hardware used to be used for the VPNs. Later on, these all were end of life, and then the Cisco ASA was launched in 2005 as a single product where you could keep policy NAT. There was a module provision to keep the IPS IDS and the device which is capable of VPN. So VPN, the policy, certificates, SSL, a unified product. And after 20 years, close to 20 years, then the need for the next gen firewall was evolved, and then Cisco purchased some third party company called SourceFire, relabeled it, remanufactured new devices, and then is how the FTD got introduced, the firepower that nowadays we use it. So this is a very basic like transition from the Cisco PICs to Cisco ASA, then to the FTD. Now, why we still have our roots with ASA? Because the next gen firewall come with a different series. Like we have Firepower. Now these Firepower are ASA plus the FTD, or I can say the next gen firewall features. So collectively, they act as next gen. And also there are a dedicated series which is completely a single unified module. We don't need to have a ASA. It's a complete FTD with the next gen features. Okay, so these are the different options available in the case of Cisco firewalls. So ASA being there for like last 15 to 20 years, but before ASA was also there, there were some type of basic firewalls. And as you know that ASA got end of life 3 to 4 years back, and then a lot of companies switched over to the next gen firewalls. So next gen firewalls, you can compete with the other vendors like Palo Alto, Checkpoint, FortiGate. Okay, it has all that quality which next gen firewall needs to have. So let's start with a very ground level. What do you understand by a firewall? So anyone here who is never into this technology, a pure routing guy?
Yes, I am not in firewall till now.
Okay, I
Yes.
hope you are at least a routing engineer.
Yes.
Okay.
I know firewalls, how it works, but like, yeah, I haven't in the firewall till now.
Okay, all right, no issues. So router, basically what happens in routers are, there are three planes here. We have a management plane, we have a data plane, and a control plane. So any incoming traffic, when it hits on that ingress interface, there are two types of traffic can occur. Either the traffic is passing over or a traffic is originating. So if it's a traffic, a ping traffic, or it's a routed traffic, basically, so it can forward via the data plane itself. So let's say this is a data plane. It will go via data plane. It will first check uh, the exit path, and it will go through the router. In case if it is a BGP process, or it's a OSPF process, or any routing process, so in that case it will go to the control plane. Control plane is where the routing table of a router sits, and it checks how the destination to be reached, and then it will process it. Okay, so this is what happens. So the main concept here is a routing table. It will first check if that's present, if a route is present or not. If route is not present, then it will drop. If the route is present, then it will pass it. But in the case of firewalls, the concept is a bit different. They have something called implicit deny. So if I have an incoming packet, now it don't actually check for routing table. It will first check whether this interface has any allow policy or any deny policy. Okay, whether it has a allow policy or a deny policy. In case if it doesn't have either one of them, that is what is said as a implicit deny. By default, it is set to deny it. So all your packet which are trying to reach somewhere, by default would get dropped. So how do you allow them in scenario like you really want that packet to be transmitted? So in that case, you will write a allow policy. Policy are nothing but ACLs. Okay, in simple word, ACL, extended type ACL. If you open up the ACL policy in a traditional firewall, it will be very similar to the policy that you write for a router. But on next gen firewalls, on these policies, you can add many more things. The next generation components, you can add it. Okay, so we'll come to that later. But let's first finish what is firewall. So in the case of allow policy, in case the device finds there is a rules which is set to allow this source to this destination, this source port to this destination port, then is when it will check all the remaining things like NAT translation, VPN traffic, routing table, switching, etc., and then it get cleared from this or exit from this. Okay, the packet process is different in firewalls and routers. In router, it is by default to allow. If you want to filter the packet, you will apply some ACL. There are two types of ACL, standard and extended. In the case of firewall, it is by default denying all the packet. Only when you write a policy, you will allow the traffic from source to destination. Firewalls usually let's say can be written as a traditional or next gen firewalls. So traditional in the sense that only check source and destination and then make a decision whether to allow or deny. But in the case of next generation, along with source and destination, it will check the other factors like deep packet inspection, where it will inspect the packet, whether it's a HTTP packet, is it a digital signatured packet, is it a JPEG format, or it will check the data there. It will classify the data that this is a video packet, this is a HTTP packet, this is a image packet, right? So it will classify in the DPI. And along with that, there is something called as threat intelligence. So let's say one file was downloaded on the same day, nothing happened. But after 4 days, you see some symptoms that the device getting infected and that file getting replicated on different devices, right? So how do you trace them? And how do you quarantine these files or these infected devices? So this is where the threat intelligence happens. The firewall, even after downloading, will keep a trace of what was downloaded. It will observe whether that unknown file really is infecting your device, what is the symptoms, what is the behavior, whether it's getting copied to another system and infecting the second system, and accordingly it will block that file. Okay, so that is threat intelligence. And along with that, you can have antivirus added, anti-spyware. So these are some next gen components along with the app ID features, the content ID, the user ID, the behavior of user. These all make the next gen firewalls, whereas a traditional only will check source, destination, and then allow or deny as per the administrator, however he would have done this. Okay.
Sagar, I had a question here.
Yeah.
You mentioned that this firewall will just look at the policy. If it is a deny, it will just deny it, right?
Yeah. Yeah.
If there's not but the route lookup needs to happen first, right? For the firewall to know whether traffic needs to be routed from like inside to outside or from outside to inside to look up the policy.
That comes later on, actually, not at the first. There are a 10 steps packet process flow in a firewall. So the route lookup happens in the 11th to 12th. Guys.
So how does the router know, like, this is the policy, I need to just deny it, I don't have a policy for it?
We'll come to
Okay,
that. You
sure.
have a background noise, so let me mute you. Okay. So if you have a background noise, please feel free to put in the chat. I have visibility to that. Okay. So we'll come to the route. We'll come to the packet flow. So don't worry. We'll cover it up. Okay. So any question with the firewalls and a router?
No, nothing from my side.
So from OSI layer perspective, you know that router fits in layer 3, whereas the traditional firewalls sit in layer 3 to 4, and the next gen firewalls are capable from layer 3 to layer 7. Okay, because there is where the application comes and need to be inspected. Okay, now regarding types of firewalls, as we know, there was something called the traditional. The traditional can also be called as packet filtering firewalls. Then there is something called a circuit layer or circuit level gateways. Then there is something called as stateful firewalls. There is something called as next gen firewalls. And nowadays there is also something called threat intelligence or threat focused next gen firewalls. Okay. Packet filtering is very basic firewall. Like I can say a Cisco Pix is a best example for packet filtering, where you put the source IP, the source port, destination IP, destination port, and you will allow this or deny this. That is what happens in a traditional thing. Whereas in a circuit gateway, these are for application based firewalls. So it cannot run by itself. It needs to run along with firewalls plus the circuit level. The additional thing that it provides the security feature is that there is a valid three-way TCP handshake to see whether the packet is genuine packet. It's a TCP error mechanism, etc. So that is one extra step. But remember, this is from the application perspective only. Okay, it's not something for a pure data traffic or VPN traffic. It's for application, any TCP connections or all those things. So it needs some sort of firewall along with this. Whereas stateful inspection are nowadays all your firewalls are consisted of. So we will take this in detail, what stateful does. So let me tell you that all your latest firewalls are following the stateful trend. They keep a session monitored, or they keep a record of each session. As you know, that next gen firewall, they are stateful. Along with stateful, they have the advanced features like IPS, IDS, threat intelligence, deep packet inspection, anti-spyware, anti-virus, all these things. And threat, as I was telling you, the history of a unknown downloaded file. Keeping a history of a unknown downloaded file and make sure that the files are not infecting the systems. In case they are being, then to block it and also block that file being getting downloaded in the near future. Okay, so that is what the threat focused next gen firewalls are. Now let's first find out what is stateful. What is stateful or what is stateless? Do you have any example for stateless?
Router.
No, you can think about ACL. Okay, the access lists are considered to be stateless, whereas stateful, I'll keep a record. Let me tell you this way. So in the case of stateful, let's say I have a firewall over here and I got a firewall over here. And behind that, I have, let's say, switch, and I have a server or a PC. Now let's assume that this is a source with 1.1.1.1, and the source port is 3389. And the destination IP that it's trying to reach is 2.2.2.2, and the destination port that it is trying to take a SSH. Let's say 22 TCP is the port number. Now this is a packet. Agree? This is a packet. The packet which will enter the firewall. The firewall will check two things, whether it's a allow or deny. So it will check for a policy, in short, and then it will allow to the next guy, and the next guy will respond back. So let's say this is a packet number 1. Firewall has no information about this packet. So this packet is now traveling over here. As soon as it reaches the ingress, it will check the policy. Policy says allow. Now the packet moves forward. Okay. And let's assume this is also allow. It hits the PC2. Now what happens in the PC2? The source becomes 2.2.2.2. Source port becomes 22 TCP. And now the destination is switched to 1.1.1.1. Source port is 3389. Now this is a packet number 2, which can also be called as a response packet. So this is a request packet, and that's a response or reply packet. Packet number 2. Now the packet number 2 comes back. Okay, and when it hits on the interface, let's say gig 0/2, what happens is the stateful feature of the firewall is checked. As per the stateful feature, if the source destination matches with the source destination that it has already processed, it doesn't need another rules to pass it on. So without having any further rule at the egress, now the packet comes back to the original source where the ping was initiated or TCP/22 was initiated. So this is called a stateful feature of a fire, where it monitors every session. Every session is monitored, or a track is kept. If it see that the source and destination match with the record, it do not need further processing of that. See, what is the other processing? It will check whether it's a VPN. Then if it's VPN, it will encrypt, decrypt. It will check if it's a SSL certificate or HTTPS traffic. It will see whether session is created. It will check whether the policy. So lot of things can be reduced, and this is done so that you can reduce the overhead. You know that something went from your side, and if you're getting a response to that, why do you want to process it via 10 to 15 step, right? So this is what a firewall does. It keeps the stateful feature. These stateful features are by default on. You cannot disable them. So now you might be wondering, in case it's a one-way communication, I only need one way. So how can I still block this? I don't want the return traffic coming back. So in that case, you have to add a policy for deny. Anything coming to this should be denied. So that what happens? Your traffic is only one way, and you're not bothered about the reply or the response. But in case, I'll give you, this was a scenario 1. Scenario 2 is in case you want bidirectional. So this stateful feature helps you. You don't have to put a bidirectional rule. The number of ACLs can be avoided. by having the stateful feature enabled or kept enabled, or it's already enabled, right? So this is what the features or benefits of having a stateful. And if you want to block the return traffic, then you can add a policy to deny if you don't need a return traffic here. So you understood what is a stateful here? Yes,
Yes.
no?
Yes.
Okay. Do you guys know what is a proxy server? Which most of the time in a security world, you might have heard about a proxy server. Okay, see, in case of firewalls, in case of security, sometimes what happens is we try that all the client packet first comes to this proxy server, then the proxy server we add some policy, and then that decide whether to allow or not. Okay, so let's assume I have some user machine. This user machine was connected to a NAT capable device, and that is going outside to the cloud internet. And behind internet, you have the various destination. You have Facebook, you have Google, Insta, and lot of other things. Okay, or also let me put torrent, poker, these insurance providers, etc., etc. Usually what happens is I don't want to invest a huge money on firewalls. Neither I have a respective person who can handle these writing policy, deleting policy. So in such cases, there comes some software-based servers, which you can also call it as proxy server. Under proxy servers, you can configure some rules. These are like software-based rules, and in the rules, you can classify the categories and the actions to be taken. So let's say if it is a social media, then yes, you would like to pass that. If it is torrent, no, you want to restrict. If it is a video streaming, okay, like YouTube or something, let's say you want to disable that. Similar way, let's say gambling site or whatsoever, poker or whatever, you want to put a no restriction. So now in this case, what happens is, if you initiate, let's say the client unknowingly is typing fb.com or facebook.com. Okay, so his packet will first go to the proxy server, first request. The proxy server will say that social media and these are on or allow. Now it will go via the router, packet number 2. The packet will come back, third packet, which is a reply for the request you sent, and then it will process to this. Okay, so proxy is acting as a firewall now. Let's say the packet is coming for a torrent, okay, a torrent website or something. So in that case, what happens? It first reaches to, okay, let's say it first goes to this. As soon as it goes there, the torrent is being disabled. So it will just say that this is to be dropped. The proxy will not process the packet either. So this is what the proxy server does as an intermediate guy here. There are two types. One is the implicit proxy server. The one which we discussed now, it's an example for implicit, where the first point of contact are the proxy servers. But then there is also one more type, which is called transparent proxy. In the case of transparent proxy, the traffic first hits the gateway. So this is the first packet. The gateway will send that second traffic to the proxy. And that needs to be checked. And if let's say that it's yes, then it goes back to the cloud or whatever, third. Then it come back and then it's been forwarded to the PC. So there are two things. One is transparent proxy and implicit. In under implicit, your point of contact is direct proxy server. Whereas in transparent server, it will hit whatever your gateways, and then gateway will send to the proxy, and that is how it takes over. Okay, so these are for especially for your traffic, like your URLs or your browsing activities where you want to block them. So what are the advantage using a proxy server? The advantage is that you can have URL filtering enabled. You don't need a very costly device. So some small scale company who do not want to get into a costly offense, so they can go with this. But there are disadvantage too. The disadvantage is that the process can be bit slower because of 3-4 steps involved here. So I can say that there can be delay. And what if this goes down? So if this goes down, there is a method of high availability, HA pairing, standby and primary. But again, if you have only one, then single point of contact, which is a delimit. If you keep two, then at least you can bypass this. Okay, proxy server, stateful feature.
Sagar, I have one question.
Yeah.
See, already the next generation firewall is taking care of this kind of rules like web filtering, everything. Then why do we need again this proxy server? Here you indicate like the social media.
We are not starting with next generation. Remember that we started with ASA. So from ASA perspective, these are the terms that we are coming through. Once you get into the next generation firewall, then definitely these will be not required. But again, next generation firewalls are very costly. Not everyone can accommodate that. So some like small scale industries, they still go with the free softwares like CyberRoam, PFSense. There are a lot of people who go with PFSense still.
Okay.
Okay, have you guys heard about transparent firewall?
Yes, it's the L2 firewall, but
yeah. So
No.
yeah. So let's say this is computers. These are computers connected to a switch, router, and then going out. Okay. What happens if I would have kept a firewall all of a sudden here? The packet will start getting dropped. Right? So keeping a firewall intermediately in your network can cause the outage. But how would you configure the things, bring it in a production, etc., etc.? So in that case, what you need to do is you can make your firewall act as a transparent. So transparent is very similar to your layer 2 capability. So this fall under layer 2, and this will fall under layer 2 interface. Okay, they will start switching the packet or switching the frames, I can say. Right word would be frame. They don't even route the packet. Instead, they will switch the frame. So they act as a invisible product now in between these two. And later on, in once you have put or replicated all the policies, you have all the allow, deny rules, and then you can convert from transparent to the routed mode. So routed mode is when the firewall start acting as a firewall and the policy comes into picture. And by then you might have taken the allow and deny in a proper way. Okay. So transparent is when you plug the firewall to not act as a firewall, but act as a layer 2 device in the network. And this will not trigger any outage. You do not need to put all the policy instantly on the firewall because you know it's an implicit deny. You have your own time, configure them, try to understand what type of traffic flows over in this firewall, what needs to be allowed, what needs to be denied, and then you can uh, put the necessary policy and convert from transparent to the routed mode. So this is doable. It's one. Don't think that once you make a transparent, then you cannot convert into router. It's very simple. You just change from transparent, put a IP address on over onto them. Then it start acting as a routed mode. Okay. What do you think happens in a next gen firewalls then? So we know proxy, we know basic firewall, we know transparent. So in case of next gen firewall, what is what we achieve here? Let's say this is PC1. It's sending some traffic here, and then the traffic goes out. Okay. So two things happens. There will be a request and there would be a reply for that or a response to that. So over here, you need to define what you need to do. So let's say drop or allow. The action needs to be set. So when a data tries to hit on the incoming interface, gig 0/0. So you need to define the action, drop or allow. Okay. And along with that, the data can be a known or unknown. So let's assume that data is known. The firewall already knows that it's a HTTP traffic or it's a voice traffic. It's called categorization. So data is known. The policy will now only check yes or no or drop or allow and do the necessary things. But what if the data was unknown? If a data is unknown, you know that in next generation firewall, you have DPI concept, you have the app ID, content ID, etc. So in this case, what happens is the next gen firewall got some concept like wildfire. This is in the Palo Alto. In Cisco, there is something called as Cisco Tal OS. Okay. So now these are a cloud solution. So in this case, the next gen firewall has a capability to send the information to the cloud. These are vendor cloud. If you are making use of a Palo Alto, then basically there will be a Palo Alto cloud, which is called Wildfire. And if it is a Cisco, then Cisco have a service provider called Talos. So whatever unknown data or unknown packet, that information is sent to the online cloud. So this is also called sandbox feature. And in a real time, it will tell whether that's a known or it's unknown concept. And then what to do with such thing, whether you want to allow or deny. Okay, so this happens in a next gen firewalls along with your traditional basic things. If it is a known, it will do the traditional method, source and destination, and that's all. If it is a data where it's a unknown, then it can also interact with the online cloud. For this, the internet is needed. That is why most of your firewalls will have the reachability to internet, because of all these things, the license upgradation, uh, the the virus information updates, the IPS. For all these things, there will be active internet. So there is how the blacklisted or malicious IP in the backend get updated in the firewall scenario. Okay, so now we will come to the packet flow of Cisco ASA. So whether ACL comes first or routing comes first, or what exactly happens. PC1 1.1.1.1 connected to a switch, firewall, FW1. Let's assume there are two types of traffic available. One was via VPN, and the second one is via internet. Internet traffic. And then they reach the other side of firewalls. Same behavior, a switch and a PC. Okay, which is 2.2.2.2. So this is a complete VPN traffic and internet traffic. Now let's assume from source IP 1.1.1, port number 3389, destination IP 2.2.2.2, TCP 80. This is the packet information. Okay, so this packet hits on the ingress interface of a Cisco firewall, which is 0/0. So step number one from the packet flow of Cisco ASA is, let's say packet is received on gig 0/0. The second step that happens is the buffer counter of the interface increases by +1. So buffer counter of that interface increases by +1. The third step is to see the connection table. So connection table is nothing but the stateful feature that we discussed some time back. Whether the connection is available, the connection is not available, that is what happens in this. So let's assume that this is a packet number 1. It's a fresh connection. So now in that case, what happens is it will see whether the TCP state is good or not. It's a TCP request or it's a UDP request. So TCP state or UDP state. Then it will see whether it's a translation or it's a untranslation. The traffic has originated from in to out. So these traffics are these are untranslated as of now. If it was a out to in, could be they were VPN capable or they were translated. So right now they are in to out. So we will say that the traffic is untranslated. There is no NAT happening to the traffic. Then it goes and check whether ACL is allow or deny. Okay, so the ACL comes first now. ACL is allow or deny. After that, there's something in ASA which is called modular policy framework. So as per this, we can set some additional features, additional configuration between layer 5 to layer 7, like TCP, timeout, etc., which override the basic timeout values. So if you want to write a customized policy on QoS, TCP timed out. So this is what is a feature called modular policy framework. So the packet will be inspected via MPF. Then it will check whether there is a next generation firewall modules. It will then check whether there is something called IPS IDS module. There is a module called IPS IDS in the case of ASA. Then is where the route lookup happens. So in this step, the route lookup will happen. Then the translation is checked. Translation based on the source. Okay. And then it goes to the dedicated module in case if it is present. So let's say right now it's not available. Then it goes to the egress interface or the outside interface. And then it will check two things, whether the traffic needs to be pushed via this or pushed via this. Okay, there are two paths to go out. Now, source destination, it depends on your policy of this. If this is the same parameter that you have set, then yes, it will take the VPN. So let's say for now, this is the same policy that you have set. Okay, so in this case, the VPN is yes. So this is a VPN traffic. Then it checks the L2 resolution, and the packet is transmitted from the egress interface. So it can take internet or the VPN traffic. So let's assume that VPN is what you have set in this case. So the VPN traffic will be captured in this particular scenario. So in what case the internet would be picked up? So let's do some modification. That would be the scenario where you have a NAT router or you have enabled the NAT feature. So you have a NAT feature. You say that all the let me write one rule. NAT, anything inside to outside should take a NAT inside to outside. Let's say source to be any dynamic internal LAN PCs coming from 192.1.6 coming from 1.1.1.0 and going outside should take this public IP. So this is one NAT rule. I can also call it's an example for PAT, where the users are browsing and I want my internet path to be taken up, not the VPN path. So in that case, it's once again start for packet received, buffer, connection table, TCP state check, untranslation is not required as of now. Let's assume ACL is allowed, MPF not applicable, next generation not applicable. And in the case of route lookup, what happens is, okay, it will check the destination. Let's say destination is reachable, 211.1.1 is reachable. It will see the translation here in the NAT rule. So as per the NAT rule, it says that anything from inside going to 211.1.1 should take this IP or any other IP. So in that case, what happens? The packet will change here. Now the source becomes whatever you have provided in the public. Okay, so this is not 2. Let's say 8.8.8.8. So here the source becomes 211.1.1.1. Port number it takes 3389. Destination needs to be 8.8.8. Okay, and this is what the traffic will be switched to internet now. Okay, so it is about how you configure on your edge router or however on your firewalls, whether you want to go via internet or VPN, and these steps are what they get repeated. Okay, Now there can be one more problem in this kind of thing. What if the user 1.1 wants to go via VPN only, but you have put a broad range here, the complete /24 you have kept. So how is that 1.1 gonna still go in the VPN? So for that, you introduce something called identity NAT. Okay, so as per identity NAT, I'll say inside to outside, sourced by 1.1.1.1, whoever is trying to reach to this destination, let's say 2.2, or let me put 2.1.1 itself, 2.1.1.1.1. Okay, any this user, let him take this IP and put the condition like if destination is 2.2.2, which is over on the VPN. So in this case, what happens? This policy will be matched, whatever VPN policy you have put, and it will take this. Okay, the translation will happen. You're just resolving it to the internal network itself. You're not adding this in this case. You will just disable this. You will say that you want to resolve 1.1.1 back to 1.1.1, going towards this destination, then make use of this one and keep this identity rule above the dynamic or NAT rule. So first this will be checked, and then only it goes to the next statement. So first your identity will be considered. It will take the VPN path. And in case if this is not the right condition, then it will take for all your different users via the internet. Okay, this is where the browsing happens. And this is where the secure VPN data will pass. So did you get this packet flow? Okay. Do you guys know how many ways we can deploy the firewalls? They're usually a hardware, software, nowadays cloud, AWS, Azure, GCP. When it comes to software, then you can have it deployed on a hypervisors like VMware. Okay, VMware EXI workstations, and hardwares are the on-premise devices. So Cisco ASA had something in this 55, starting with 5505 till 5585. These were pure ASA devices. Once Cisco acquired SourceFire and introduced the firepower features, then you started seeing something called as, okay, now let me write it this way, something like this. Okay, see, I think there can be some confusions here. Let me put it in this manner. So your traditional ASA firewalls, they used to be 5505 till 5585, and Cisco ASA with firepower, they are basically in this representation: 5585-X, 5565-X, 5535X. So wherever you see this, just think about that model having both ASA and firepower feature. Cisco also introduced their own hardwares, the FTD hardwares. which do not run on top of ASA. Okay. So these models are all your 64-bit Intel chips, whereas these used to be the 32-bit of Intel chips, the older ones. Okay. So a small history from the transition point, how Cisco came into the next gen world. So as you already know that there used to be Cisco PICs, then ASA came into picture, and then there was a company which is called as Sourcefire, who were already into the NOT process. NOT process is the packet flow or packet inspection in the Cisco FTD scenario. The packet flow that we saw some time back was for ASA. For the next generation firewall, Cisco make use of this technology. Okay, so in the year 2001 was the Sourcefire being launched by a person called Martin, and this was doing very well. Cisco wanted to get into the next gen technology. So what it did, it acquired this company. As soon as this acquired this company, there is where the product like 5585X started releasing up. There were also some dedicated firepower devices like 210041. There were some ISR routers too, which were also integrated with the NOT process, a firewall, next gen firewall module inserted into this. So this is when the first stage of acquisition happened. Okay. Later on, what Cisco did is Cisco thought of rebranding, and they rebranded this to something called Firesight. Also, let me tell you, there were 3 versions that was launched over here: V4.x, version 5.x, version 6.x. So version 4.x is when the Sourcefire were considered. Version 5.x is when the Firesight was launched. And then 6 onwards, they are all FTD models. So in the case of Firesight, the rebranding happened. It was around 2013 when the Cisco rebranded all Sourcefire to Firesight. But there was one problem now. The problem was in V5.x, the centralized controller, you might know the centralized controller, not centralized, the management here, there was something called as ASDM. And in the FTD, there are 2 management. One is FDM and one is FMC. So this FMC was also launched in the case of Firesight. But at that point, that was called as Firesight Management Control or Management Center. Okay, so this started leading problem or confusion with this, the branding. And then is what they thought that let's convert into something called firepower or something like this, firepower. Now there are 2 ways the firepower are used. One is that you will see sometimes people writing this, where power is all in uppercase. So that is when ASA with firepower module can be integrated. You will also see sometimes people only write this, all in lowercase. So this is when the unified FTD models are referenced. The unified model with both ASA, firepower, and other blades inserted, a single box. Okay, so these firepowers, they consist of 2 what do you say, 2 appliances. One is management appliance, and second one is called the sensor. So management deal with all your management related traffic, and sensor deal with all your network traffics. Okay, where all the inspection and all those things happens. So this is a short story. And as a centralized management, FMC is something which can centralized or central management point for all different appliances. So you can have multiple FTDs kept. Whereas the FDM, this product, they are still locally significant. So one box, FDM, second box, it's FDM, third box, it's FDM. Similar like ASDM. ASDM used to also be locally significant. You have ASDM, you have ASDM, you have ASDM, right? It used to be very difficult when you have 10 device, you have to open 10 different ASDM. You have to put IP, first IP, then the second, then the third, etc. But now with the help of FMC, you can onboard all the individual FTD to this, and you can centralized push or control them. All right, guys. So I see it's 11. So we can wind up here. If you have any question, you can let me know, and tomorrow we can continue with the hardwares and different softwares.
No questions. Once we will go through, if you got any questions, we will ask.
Okay, fine. Let me also tell that.
Sagar sir,
Yeah.
good evening. At what time you started this class?
See, today it started at 10 p.m. India. Okay, and we had a 90-minute session. Once our checkpoint session is over, then I'll keep it by 9 p.m. and I'll take it a 2 to 3 hour of session. So might be we can have 9 to 11. That is 2 hour session. Okay.
Because I'm joined other link and there are other trainers.
Which one?
I think Akhil.
Yeah. Don't join that session. That is not meant for you.
Yes.
Okay.
And I'm totally confused. What's going on here?
Yeah, that is almost 95% done. So don't join there. Your class for next few days is 10 p.m. I have already put in the WhatsApp group that ASA will start at 10 p.m.
Okay, so thank you, sir.
Okay. And also let me tell you, in this batch, there are two groups of people. One is Firewall Mastery, who are attending the ASA FTD module, and the CCIE CCNP Security guys who are also attending the ASA FTD. So once this module is done, Firewall guys will proceed with their agenda. They will go with the Palo Alto, they will go with Checkpoint, FI, LTM, and the FortiGate. Whereas the CCI security guys will take up their domain. So they will have the next paper like Score, they have SVPN paper, they have the ESA, WSA, security lab bootcamp. So that's a different track, and this is a different track. So you all guys are in a same module for ASFTD, and later on you guys will part away. So don't get confused. I just made clear as of now. Okay.
Okay, sir.
It looks like Palo Alto also started today.
Yes, that is also right. Palo Alto also started, but I am not the trainer for this Palo Alto. It is in the morning hours, 9 a.m. So especially those firewall mastery guys who want to like parallel module, then you can also opt Palo Alto if you can manage to.
All right, sounds good.
Okay. And also quick information about the access. few may not have received, but most of them have received the welcome kit. So the welcome kit usually consists of three things. One is the web or video portal logins, the lab access, and something called as support DL. So this is where the recording will be available, and it's a lifetime access to the guys. And the lab access, we have two models. We have home lab setup and we have a remote lab. So for home lab, we need at least 32 GB in the case of ASA FTD, because our lab has FTD, FMC, and ASA all plugged in one topology. So it will need 32 gig of RAM plus at least 6 to 8, or I can say 8 core CPU. So if you do not have this big laptop, then basically don't take up the home lab. Instead, go with the remote lab. Opt for remote lab. And for any case of technical assistance, home lab setup, you guys can write an email to the support DL, which is mentioned in the email, and get the home lab done on your machine. But remember, this is what you need to have, 32 GB.
I have 20 GB RAM, sir. It's
Very difficult to run because FMC itself will take 8 GB and FTD will take another 8 GB. So FMC sometimes need 16 GB too. So you go for the remote lab.
Okay.
Okay, if you guys have not received, wait. Tomorrow is Sunday, so I doubt. To wait till Monday. Monday evening, you can just remind in case if you have not received. Okay. Okay, I see one
I
question.
received the welcome kit. There are one link, but when I go for the opening the link,
Okay.
I received some types of error.
Okay. So Palo Alto, Saturday, Sunday, 9 a.m. Today was the first class, and Cisco ASA FTD. Once again, Saturday, Sunday, but in the evening. Right now it's 10 a.m. 10 p.m. But then we will switch it to 9 p.m. Okay. So this is the quick intro of today's class and basic firewall and the basic next gen, etc. So tomorrow we'll start with the FTD hardwares, and I'll show you the lab and etc. So I hope we are all on the same track now, right? So any doubt, you can ask me.
Sure.
Okay. All right, guys. Thank you, and let's connect tomorrow. Thank you. Have a nice day.
Thank you. Bye bye.